Hello, welcome to class. Today we are going to continue with our topic, the reliability of complex systems. And when I mean system, of course you know that we mean engineering systems. In the previous class, we looked at other methods and many other aspects of systems of engineering. But today we'll be looking at method of decomposition for analyzing the reliability of complex engineering systems. In the past, we have already looked at engineering systems that are series in configuration, engineering systems that are parallel in configurations. We have also looked at series, parallel series, and all those kind of things. And we looked at how to evaluate the reliability of each of these systems. Also, last time we looked at some methods for evaluating the reliability of complex engineering systems. The two that we looked at in the previous class are the method of minimal part sets and the minimal code set method. Today we'll be treating the third one, which is decomposition method. Of course, there are other methods, but in this course we'll be limited to just these three. Let's consider this system. This system is a system that resembles one we have studied. You can see 1 and 3 in series, and then 2 and the element 2 and 4 are in series as well, and then the two of them are in the 2 and 3 and 2, sorry, 1 and 3 and 2 and 4, they form parallel combination. So to evaluate this, we don't have issue with it, so we can do it easily. But imagine we have the fifth element, which is block 5. This system will become complex because it's neither series nor parallel. This is like a bridge circuit or system. So how do we go about this? We looked at last time we could do this with minimum parts set and also with a method of a minimal code. But today we'll be looking at how to use decomposition method to solve this, and you will verify that we'll get the same thing if you look at it. To apply decomposition method, I'll outline some steps that we are going to follow. The first step is that you are going to choose a pivot element. Some call it key element, some call it the cornerstone element, some call it other thing. But it is normally that element that makes the system complex. In our case, it is block 5 or element 5. If you remove this element, the system returns to series or parallel system that we have studied in the past. The second step is, after choosing this pivot element, you are going to build two different systems or subsystems, system A now and system B, which are part of this main system. System A is the system that you get assuming that block 5 is operational, that it is working, it is in good condition. To understand this better in computation, assume that block 5 is now a short circuit, meaning it is a simpler way of understanding this, because I know you ask, how can it be short circuit when it is working? That is the method of decomposition. And in the second system is system B. In this case, it's assumed that element 5, which is the pivot element, is not operational, it's faulty. We understand this easily by assuming that it is an open circuit. That is, we'll remove this entirely. The third step now is to evaluate the reliabilities of the subsystems. That is the reliability of the system A, which I'm going to call RA, the reliability of system B, which I'm going to call RB. And then finally, after evaluating the reliability of the two, we will now look at the overall reliability of the system. So we'll see this detail in the next slide. Okay, the first system, or the first subsystem, which is now system A, which I say like you short the element 5, you make it a short circuit. So you can see 1 and 2 now becomes in parallel, 2 and 4 are now in parallel. We can do this easily by just evaluating the parallel combination of this. Of course, you know how to evaluate reliability of a parallel system. So we evaluate this in parallel, 1 and 2 in parallel. We evaluate 3 and 4 in parallel, and then we evaluate the combination in series. So that is simple. The other second, the subsystem, is formed by making element 5 open. So in that case, it becomes the simplified system that we know very well how to handle, which is 1 and 3 now in series, 2 and 4 now in series, and then the combination in parallel. We have also looked at that in the past class, in the previous class, and I know that you can deal with this. And don't forget also the reliability of that element, which is element 5, which is now the pivot. Assuming that the reliability of that element is R5, then the overall reliability will now be given as the reliability of the subsystem A multiplied by the reliability of element 5 plus the reliability of the subsystem B multiplied by the unreliability of element 5. Another way, it is the reliability of system A given that element 5 is in good condition multiplied by the reliability of element 5 plus the reliability of system B given that the element 5 is 40 multiplied by the unreliability of element 5. So this is how to go about complex system using decomposition method. Thank you for listening, and I can entertain your questions.